the standards that are commonly used, the standard absorption rate SAR, in your opinion, is that adequate and accurate?
Well, I assume it's reasonably accurate. People say that it can be off by a factor of 2 or 4, which means that it's not, companies are not all that careful about how they make these measurements and how they publicize them. But that's the physical measurement of the amount of energy. And when you're interested in the biological effect, the energy that's put out is not necessarily correlated. In fact, there's no correlation at all between the effect of the biological effect that you can measure and the SAR. And there are 2 effects that have been documented biologically that indicate that very clearly. The first, and that's one that I've worked on personally, is the stress response, which occurs at SARs that are, remember, something like 10 to the minus 11 watts per kilogram, which are the units of the SAR, in the ELF range at 60 hertz, whereas in the radio frequency range, it occurs at 10 to the minus 1 watts, which means it differs by over 1 billion-fold. It's the same biological effect turned on by very different amounts of energy that are input. So that means that it's not terribly effective. It's inadequate. It's wrong. It's just not a measure of what we're looking for. And the other effect that I can point to is the breaking up of DNA, and that's work that's been done by Henry Lai and others. And they have found that the DNA can be broken up in the low frequency range and also in the radio frequency range. And we know very well that it's broken up at a much higher frequency. Cosmic rays that are the other, all the way at the end of the electromagnetic spectrum, do a great job of that. So the biological effects go over a vast range of energy distribution, and the same, more or less, I guess it gets a little more intense with regard to the breaking up of DNA, but qualitatively it's the same biological effect that's taking place. So if you want to measure a biological effect, you have to measure a biological effect. And a physical surrogate is, I mean, it's not a good way to measure biology.
Can you, for the lay people, explain what the implications are of breaking DNA?
Well, DNA, we all know, is contains the code of life. It's the genetic material that every cell has, or virtually every cell has, and that we go through with this information from the time we are conceived. But it gets damaged during lifetime, and the damage that hangs around that's not corrected is damage that we call mutations. And the mutations in DNA are correlated with with cancer. That is, that's believed to be the first step in the development of cancer. So if you get a lot of these damaged DNAs hanging around, it's not good news for the future of the cells and organized growth and development. You get this erratic growth and tumor development, things like that. So I would say it's bad to have these things. You try and avoid them. The body avoids them. The body has natural mechanisms that correct these the damage, but it's not 100% efficient. So it works well, very well, but not 100%. So you want to avoid the damage so that you're not left with any residual damage. Mm-hmm. There are problems that we have with cell phones that have not been investigated, and they should be, because here's a product that's the public is using. It's having causing biological changes, and one isn't quite sure whether it's causing very harmful ones. And there is some evidence that it's causing cancer, brain tumors in particular. So I think it's important that the money be put aside in the budget for investigating this problem.
What is the most important thing that you could say as a scientist to the layperson about the use of cell phones, wireless technology in general?
Well, as a scientist, I have a very different list to tell them. I mean, I'm interested in finding out, well, how it works and how we can control it if possible. But for the layperson, I think you got to learn to just avoid it as much as possible. I think that the device is very handy, and it's addictive. You can see people hanging on that thing for, you know, endlessly, more or less. People walking in the street, people driving, just, and I think it's unhealthy to keep a device next to your head that's generating radio frequency and pouring those waves, those rays into your head and areas where it's going to affect the cells, and where there have been cases of tumors that develop in those areas. And we recently had the case of Senator Kennedy, which everyone believes is probably caused by that, or at least certainly contributed to by that. He also lived in an area which is very heavily covered by the radar stations that they have in that area too. It's another source of radiation. It's another point that if you, I guess, talking to the lay people, I think that the cell phones is what people are focused on these days, but there are a lot of other sources of electromagnetic fields in the environment. And the interesting thing, that carrying on from the point I mentioned earlier about the biology occurring all over the spectrum, same biology is occurring with all of these things. So if you're sleeping next to an electric circuit, let's say you've got a lamp or an electric clock that's near there that's pouring out this stuff, you may be influencing the same kinds of processes that the cell phone is doing. So you've got to become aware of all these things, and the thing is that you cannot become aware just by thinking about it or feeling it, because we don't feel it. You need a meter. You need somebody who can measure this for you and tell you that this stuff is there.
Well, and do you have any comments about the effects on children being different?
Well, the effects on children are like most things. Children are growing, and so whenever you know, as the twig is bent, so grows the tree, you know. You make small changes in a child, they'll be magnified as the child grows and develops. And you cannot avoid that. That's inevitable. They're metabolizing faster, their cells are growing, and but with cell phones in particular, although the brain is pretty large in a child's head in comparison to an adult, it's about the same size, I was told. A 5-year-old has a brain about the same size as an adult. But the tissues are not the same size. I mean, the cranium is thinner, the tissues are more permeable, and so if you hold a cell phone up to the head, you're getting much more radiation going into the head. And so children are particularly vulnerable because they're getting more dose for the same kind of contact, and the cells are being harmed. At least those that are harmed are going to be reproducing more often and for longer time than the adults.
Mm-hmm. So what would your recommendation be?
Oh, well, kids shouldn't. I think for a while, I think it was illegal to sell cell phones to children. I think England, with the Stewart report, I think they said that one shouldn't sell cell phones to children. Children being, I think, 15 or 16 or younger. I think the French have just outlawed the sale of these cell phones designed for toddlers who cannot read or type, or so just 2 or 3 buttons on there so they can ring their parents. No, I think children, it's not a toy. It's a device that needs to be handled carefully. You wouldn't give your child a saber saw, you know, because the harm. And one should think about these devices also that way, that there's potential harm in not using it, in using it improperly.